So the first question says, given a quadratic function in vertex form, find the following. You want to determine whether the graph opens up or down. So what we're going to be looking at that is we'll look at our leading term here. I see that it's positive, so I know it opens up. Next, ask for the vertex. So what I'm looking for the vertex, I'm looking for these two shifts. So I'm looking at this, these two shifts, and so I can see that it is shifted to the left. This is shifting to the left 5, and this is shifting down 8. And so the vertex goes from 0, 0 to -5, -8. So the next part asks for the y-intercept. So to find the y-intercept, that would be where it intersects the y-axis. And so when it intersects the y-axis, that's when x equals 0. So I can plug in x equals 0 and see what I get. So f of 0 is equal to 2 times 0 plus 5 squared minus 8. 5 squared is 25 times 2 is 50. 50 minus 8 is 42. So the y-intercept is at 0, 42. The x-intercept, that will be that will be on the x-axis here. So that will be when y equals 0. So if I set this equal to 0 and solve for x. So I can add the 8 over, divide by 2. I get 4 is equal to x plus 5 squared. When I take the square root of both sides, I need to remember my plus or minus. So I get plus or minus 2 is equal to x plus 5. And then I can add that subtract that 5 over. So I get -5 plus 2 and -5 minus 2. So that gives me 2 of those zeros. So when we do -5 minus 2, that gives me -7, 0. And when I do -5 plus 2, that gives me -3, 0. Okay, so next, the minimum and maximum value of the function. I know that this function, that it is at -5, -8 is my vertex. It's opening up. It crosses here at -3, 0, -7, 0. So it's looking something like this. It's crossing there at 42. So the minimum value of the function is going to be this value down here is -8. And it has no maximum because it goes on forever on both sides. The axis of symmetry will be right here down the middle. That will be at x equals -5. The domain of the function will be all real numbers, so from -infinity to infinity. And the range of the function, we know that the smallest y value is -8, so it's -8 to infinity. Whoops, that should have been an 8. Sorry. It's hard to write an 8 and then an infinity, so -8, comma, infinity. Use completing the square to write the following quadratic functions in vertex form, then find the vertex, direction of opening, and so on. Okay, so let's go ahead and do that. So for this one, I want to complete this square. So I have f of x, so I get, I get x squared plus, and I'm going to write that 6 as 3 times 2x and then I want to add something and subtract it off. So I get x squared plus 3 times 2x, and I want to add 3 squared. So if I add 3 squared, that gives me 9, but I also need to subtract the 9 to, because I'm adding 0 in a creative way. And so what I get there is x plus 3 quantity squared, and then if I do 5 minus 9, I get -4. And so for that one, part A, it is going to open up. My vertex is at -3, -4. So looking again at those shifts there, so it's shifting left 3 and down 4, so -3, -4. And the minimum value of that, since it opens up, it's going to have a minimum value of y equals -4. And the domain will be -infinity to infinity. Okay, so the next one, number 2 here. If I write this down, I have negative 2x squared, and I'm going to go ahead and pull that negative 2 all the way out of both of those terms. So I'm going to get negative 2, and I'll have x squared. When I divide that 10 by negative 2, I get plus 5x. This is going to be plus 2.5 times 2x, and then plus something, plus 4 minus something. Okay, and so I want to add in here this 2.5. Oops, sorry, it switched to a eraser for a second there. Okay, I want to add that 2.5 squared. So this is plus 2.5 squared, and then minus, well, so that 2.5 squared is actually also multiplied by this negative 2. So I'm going to do that. So I'm going to have negative 2 times 2.5 squared. And so what I get then is I get negative 2 times x plus 2.5 quantity squared, and then I get plus, and that's going to be, when I add that all up, it's going to be, well, let's see, I'll write that as a fraction. So if I do 4 minus negative 2, so it's going to be 4 plus 2 times 2.5 squared. I'm going to plug that all in my calculator, hit fraction, I get 33/2. Okay, and so then is it opening up or down? Well, I'm going to look at my leading term. I see that leading term is negative, so I know it's going to open down. And the vertex will be at, so it's going to the left by 2.5, so it's going to be negative 2.5, comma, 33/2, which that's like, what, 16.5, I guess? Okay, and then it's opening down. Yeah, I said that maximum value. Since it's opening down, it's going to be like that, so it's going to have a maximum. So the maximum value is going to be y equals 33/2. And the domain will be all real numbers. So I could plug any number in for x and get an output. So no restrictions on the domain. Okay, so the next one. Okay, so for this one, I'm going to pull a 3 out of both of those. And so I'll have 3 times x squared minus 8/3. So I'm going to say 2 times 4/3 x. And I want to add on there the 4/3 squared. So I'm going to add 4/3 squared. And then I'm going to subtract that off. So I'm subtracting off, well, it's 4/3 squared, but it's also times that 3, multiplied by that 3. So 4/3 squared times 3. And so what I get here is I'm going to get 3 times negative 4/3, x minus 4/3 squared. And then I'm going to have minus, and when I square that guy, it's going to be 16 ninths, and then multiply that by 3, so it'll be 16/3. Okay, and so that tells me that is opening up, and it has the vertex. Again, it's shifted to the right by 4/3, so 4/3, and then down 16/3. Okay, and then its domain will be negative infinity to infinity. And since it's opening up, it has a minimum value because it's going like that, so it's going to have a minimum. And the minimum value will be the y value at the vertex. So y equals negative 16/3. Okay, use the vertex formula to find the vertex of the following quadratic functions. So we need to put those in vertex formula. So this one is exactly the same as the one we just did. So the vertex of that is given, -3, -4. I already did that one. This one is different, so we'll have to actually do that one. So if I put that into vertex form, I'm going to complete this square. So I'm going to pull a -3 out of that, and I'll have x squared plus 3x, and then I'll do minus whatever. So it should be, I'm going to do 3/2 squared. So I want to subtract, so I have +8, and I want to subtract off 3/2 squared times -3, because it's multiplied by that -3. That 3/2 is inside of those parentheses, so it's being multiplied by -3. And so now I just need to sort that all out. So I'll have -3 times x plus 3/2 squared, and then when I add all that together, I get 8 plus 3/2 squared times -3. And so I get 1.25, oh, whoops, it's minus, excuse me. So it's 8 minus 3/2 squared plus, times -3. So I get 14.75, and I guess if I wrote that as a fraction, that would be 59/4. So it's 14.75. Okay, and so my vertex, again, I'm working part B right now, is at -3/2, comma 54 over 4. Okay. For part C, I don't even need to complete the square on part C. Take a look at that. Because part C, there's no shift left-right. There's just a shift down. So the vertex is at 0, comma -5. And then the next one says a rocket is shot straight upward from ground level with an initial speed of 98 meters per second. So that's shot. So it starts here and shot straight up. It's going to come straight back down. So there's my model that represents the height of my rocket in meters, height in meters, t seconds after the launch. So the first question is, when will the rocket reach its maximum height? So I know it will reach its maximum height when we are at the vertex. So I'm going to take 98 divided by 4.9. Okay, so I get -4.9 t squared minus 20t. And then I want to do plus, I'm going to add 20 divided by 2 is 10 squared. And I'm going to subtract off 10 squared times -4.9. Okay, and so then that's going to give me -4.9, and I'll have t minus 10 squared, and then so that's going to end up being positive. 10 squared times 4.9 is going to give me 490. And so, so the maximum height is going to be this 490, is going to be the y-coordinate on my vertex. So 490 meters. And find the maximum, when it will reach the maximum height. It will reach the maximum height at 10 seconds because that's where it's shifted to the right 10 units, and so that vertex is going to occur at 10. So it's 10 seconds. Sorry, let me get here. T equals 10 seconds. And then the maximum height is S equals 490 meters. Okay, it says the data in the table represents a population of bacteria, and that's measured in thousands versus the number of hours since the culture was started. So use regression capabilities of your calculator to model the data as a quadratic regression. So to do this, we're going to go first to stat and then edit. So stat and then edit. And we're going to type in those numbers. So I'm going to pause this for a second while I type them in. Okay, I typed them all in. Now I'm going to go back to stat, arrow to the right to the calculate menu, and I'm going to go down to quadratic regression and hit enter. And so it tells me my quadratic regression model. And so the model that I get is going to be P of t equals negative 0.173 t squared plus round to 3 decimal places. Yeah, 8.312 t minus 1.3857, so 6. Okay, and then I want to find when the population is the greatest. So I am going to do that not by completing the square. I'm going to go ahead and graph that function and find the maximum on my calculator. So let me type in that function. So I went into my y1 and I typed in that function. So you can do that. If you need a pause, go ahead and do that. I'm going to think about my window here because I'm looking at my time. So I'm just going to do my window from 0 to 40. And then it looks like the biggest value I see is 98.6. So I'm just going to go on my y, I'm going to go 0 to 100. And let's see if that gives us the maximum. Yeah, there it is. I can see it. So I can go to second, calculate, it's right above trace, and go to maximum. And then it wants me to give a point to the left of the maximum and a point to the right. So it'll say left bound. So you hit enter when the blinker is to the left of the maximum, and then you arrow over to the right of the maximum and get a right boundary, and then hit enter, and then it will give you the maximum. And it looks like the maximum happens when t equals 24.023, and the maximum population is P equals 98.45 thousand bacteria. So the next, it says determine the end behavior of the following polynomial function. So really what we're looking here when we are determining the end behavior is we are looking for the highest power of the, we're looking for the highest power, and then we're also looking for the sign. And so for the first one, it says the highest power is 224, and so I know that that is an even function. So they'll be either both pointing up or both pointing down. Since it's negative, my end behavior is down, down, like that. And then for the next one, I can see my highest power is odd. Oops, I meant to highlight. My highest power is odd. Oh, well, now I can't even see it. Okay. Let's get that erased. Okay, so my highest power is odd, and then my sign is negative. So for odd functions, they'll go 1 is up, 1 is down. So for this one, since it's negative, it'll go like this. Up that direction and down that direction. And then here I have, oh gosh, I keep messing that up. Okay, so here I have an odd power and a positive leading term. So it's going to be going up this direction and down that direction. So that's for part C. For part D, I have an even power and a positive, so it's going to be going up and up. Up to the right, up to the left. And for E, I have an odd power and a positive term, so it's going to be going up to the right and down to the left. And then the last one, I have an even power and a negative, so it's going to be going down to the right and down to the left. Find the zeros and state the multiplicities of the following functions. So are we looking for the multiplicities of each zero? So we're looking at the zeros and their multiplicities for each function. So for this one, I think I can factor that by grouping. Looks like if I pull out an x squared from these first two, and then I'll have x plus 7, and if I pull out a minus x from or minus 1 from those two, x plus 7. So then I can factor out an x plus 7 from each of these, and so I'll have x plus 7 times x squared minus 1. Again, that's a difference of squares. So I get x plus 7, x minus 1, x plus 1. So the zeros are 7, and it has multiplicity 1, because there's only one at factor. Then 1 with multiplicity 1, and then minus 1 with multiplicity 1. That's the first one. The next one, let's see if I can get some more room here. There we go. The next one I can factor. So I'm going to pull out an x from actually I can pull out a 3x from everything. And I'll maybe even a negative 3x, just so that everything looks a little better. So I'll have a 2x squared plus 3x, and then minus, when I pull that 3x, negative 3x out of that, I'll get 20x. Or sorry, just 20. Minus 20. And then let's see if that factors. So I can do 2x and then x. And then let's see here. So 20 is 2 times 10 or 4 times 5. Let's see here. So if I do a 4 here, that makes an 8, and a 5 here, that makes a 5. So 8 minus 5 would give me the 3. So I want the 5 to be negative and the 2x times 4 to be positive. So I get a positive 3x in the middle. And so what are my zeros? My zeros are x equals 0 from this one, and it has multiplicity 1. And I get x equals 5 halves from this one, and it has multiplicity 1. And then I get x equals negative 4 with multiplicity 1. Okay, and the last one is already factored out for me, so that's really nice. I just have to read it off, and I can see what I have there. So on the last one, I can see that 0 will be one of my zeros, so x equals 0, it has multiplicity 1. From this one, I'll get x equals negative 3. It has multiplicity 4 because that occurs 4 times. That factor occurs 4 times. And then I have x equals 2. It has multiplicity 3. And then I get x equals minus 5, and it has multiplicity 2.